I think we're back. Yeah. Okay, so now let's quickly do the second part, okay? We'll be seeing how it goes here, hopefully. Let's go for it. Sorry for the small delay. Let's do the second part and let's see how it's gonna go, and let's have some fun. Okay, so what we were saying, I want to start with the ball. Here's the second assignment, and we're going to be doing, we want to finish differential equations. So we're going to look at the second bit of differential equations. That's what we want to look at. So, and let's see how it's going to go, or like, I'm going to start from the bottom, and I want to teach you, we're not going to use this table. Ignore all this, don't even look at it, don't try to know anything from it, we're not going to use it. Okay? We are going to work with here. I want to start with the question at number 5 and teach you how to do these partial differential equations. And if you're good at them, then we can go to the next thing, then to the next thing. Can you just confirm if I'm live? To the next thing, and we see how it goes. Hopefully. From here it's not showing. The channel itself here. Okay, good. So I was just confirming. Let's see. Let's quickly go through the question. This is going to be short. Quick, fast, short, whatever. We'll be done in no time, so don't worry about it. I'm going to quickly show you the things that you're going to have to know, and then once you're good at that, we are good. Okay? And we're going to quickly get this. So I want you to know that for this one, when you're going to get this type of question, it's a partial differential equation. When you're going to get this type of question, just look at it. You're going to have these big D's you're given and a Z. So what makes something a partial differential equation is you're now going to be having the questions you're going to meet in this section. You're going to be having, look at it, Z, X, Y. This is 3 different variables. We never had a situation like that in ordinary differential equations. So I have 3 different variables, and I have this function of Z and whatever it is in terms of Z, and it is going to be equal to these 2, and these are in terms of X and Y. So how do I get my solutions? Now let me quickly show you what we're going to do, and we move on. For this one, you should know what I don't want to feed you with too much information from every haphazard. But here, I'm going to lock it exactly into what you have to know for this one. For here, you're going to do the very same thing which we just did, the method we did in part 1. The very last thing in method number 4, where we say that y was equal to the y was equal to the complementary function plus the particular integral. When we say y was equal to the complementary function plus the particular integral, that's what we're going to do as well. We're going to get our y equal to the same things, the complementary function plus the particular integral. Now, how are you going to get the complementary function, which is the first thing you always get, the first thing you always get? How are you going to get it in this situation? Well, you are going to work with the D's. You're going to work with the D's, and you're going to try and solve and get a solution. Complementary is always, you work with these guys. This is the D operator form. So we're going to be focusing on the D operator form to get our complementary function. Then I'll show you how to get the particular integral. It's very, very important. We're not going to use the table. We never use the table for any of those things. So let's see how we're going to do for these particular questions. So this is union exam. You get this. I want you to know right now that these are easy cases. The cases you have been given here are very, very easy cases. So don't even be scared of it. It's a walk in the park. You're going to see how we quickly can solve and get. The first thing is going to be, how do I get my complementary function? Now, when you're going to get your complementary function, there are going to be things that we need you to know. How are you going to solve? It's just an equation. But how you're going to solve is, you must know this, that your D is going to be replaced by M, and then your D prime is going to be replaced by 1. In complementary function, I want you to make sure you put this. D is replaced by M, then D prime is going to be replaced by 1. Put this. This is going to be, remember D prime is like the first derivative, right? D prime. So D is going to be replaced by that, and then D prime will be replaced by 1. And that is what we are always going to do when we get a situation like that. And had we been given an equation which is not in this form, the d prime would have come from a y. Things that we'll be having in terms of y will be having a d prime. But anyway, we are getting a situation where you are already given in the d operator form. So you have already been given in the d operator form. Now all you have to do is find solutions. So we have to go ahead and find solutions, and we'll find our complementary function. Finito! Now what you must know is that when you are going to find your complementary function, I want to write this down. Look at what you should know when you're going to write your complementary function. Complementary function is always going to be like this. You're going to say complementary function is going to be equal to, then you're going to put your f1, and inside you put y plus m1x, because you're going to get solutions, m1, m2, whatever. Then you're going to say plus f2 y plus m2x. Then you say plus, you keep going, f3, then y plus, you now put the m3x. Okay, you're going to be replacing this m. F will remain as f3, but you'll be replacing this m. This is how you're going to get your complementary function. Make sure you know that. How are you going to get your complementary function? You're going to resolve. Remember, complementary function, there are things I need you to know. That for d, you're going to put m, for d prime, you're going to put 1. Then when you get your solutions for m, you're going to now say, this is going to be my complementary function. But if you get m being the same, if you are going to get 3 solutions and 2 of them you have m being the same, let's say you get m equal to 1, another m being also equal to m2 being equal to 1 as well. Once you get m being the same, when you're going to put your m1x and your m2x, you are going to increase the powers of x if a solution is repeating. So let's say m1 was 1, or m1 was 3, m2 was also 3. So that means when I'm now putting it out, say my complementary function is going to be f1 of y plus, what's my m1? 3x. Plus, here now, because there is another 3, I'm going to start increasing the power of x. So this now becomes x, then f2. Then I would now say y plus, again, 3x. Okay? If you had gotten an m3 which was also 3, you'd now say plus f3, there's an x squared, plus x squared f3, y plus 3x again. You understand? Because here, don't forget that 4. That is where you're going to put your m. Just before the x. That's where you're going to put your solution for m. Let's summarize this. Let's summarize this so everybody knows what to do. You get a situation like that. The very first thing I need you to do, it's simple. It's very simple. The first thing I need you to do is, can you replace the d's with m's? After replacing the d's with m's, remember that how you replace, you say d will be m, then d prime will be 1. Then you are now going to resolve and get values for m, and then you're going to tell us what your complementary function is. Done. And to tell us what your complementary function is, it's not like method 4 where we are coming from. Your complementary function is always in this form. Complementary function is always in this form. For here. Let's solve number 5a. We'll go to particular integral. And for particular integral, I'll now tell you tips. But it's separate from getting the very first thing, which is complementary function. You get it for 5a, you get it for 5b. Complementary function, very easy. D is going to be m. D prime will be 1. And of course you make it equal to 0. You solve. And then you're going to find your solutions, which you come and put in the complementary function. So let's do that. So let's put what we had. D squared plus 7d d prime plus 12d prime squared. D squared plus 7d d prime plus 12d prime squared. This is of z. So we're going to let this be equal to 0. And then you're going to say also now, let d be equal to m, and then your d prime be equal to 1. Which means what we actually have here, you only do this dm d prime 1, You only do when you're getting this, the complementary function for this part. So you're now going to say now m squared plus 7m by 1, which is just 7m, plus 12 by 1 is equal to 0. Okay, you can just say that. So we're going to say m squared plus 7m plus 12 is equal to 0. Solve and get the values for m. You're done. A is 1, B is 7, C is 12. D squared, D prime is D prime O squared, and D prime is 1, so it's like 1 O squared, which is a 1 by 12 and whatever. So here we have it. Now we're going to say first get B squared minus 4AC. This is going to be 7 squared minus 4 by 1 by 12, which is 49 minus 48, which is going to be 1. Really? Yeah. So you now say m is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. If you can't remember the quadratic formula, then come on. Are you serious? Now you're going to say m will be minus of 7 plus or minus the square root of 1 all over 2 by 1 all over 2. So m will be equal to minus 7 plus or minus 1 all over 2. So we have our m1 being equal to minus 7 plus 1 over 2. Then we have our m2 being equal to minus 7 minus 1 all over 2. m1 will be equal to 1 minus 7, that's negative 6 over 2, which means our m1 will be equal to negative 3. m2 will be negative 8 over 2, which means our m2 will be equal to negative 4. We have the solutions. Are they the same? No. So complementary function is very easy for this one. You put your complementary function. Let's write it down and let's put it. We say f1, then we say y minus 3x. Okay, you say plus m1, right? Minus 3x. Then you say plus f2. Then you now say y, then you put this one, minus 4x. Is this the complementary function? Yes! You're done! This is going to be complementary function. We say to you, well done. Free marks. These type of things, we don't play with them. You butcher. No jokes. Then now, okay, when you have the complementary function, which I believe you can do as well for the second one, we'll see. But remember, it is resting on you knowing that D is M and D prime is 1. Don't forget this statement. Do not forget it. And the other things, you just let B equal to 0 and whatever. Don't forget this. Okay? D is M, D prime is 1. Where? For complementary function. Now let's go to the rest. We are now going to get particular integral. Particular integral, I just can tell you, for example, it has 3 situations and they are all easy. So let's go and see for particular integral. Now, particular integral for this one is very nice because if you're doing for 2 things, you remember particular integral, you always look on the other side. If you're doing for 2 things, you'll be doing one at a time. So how do you do the particular integral? How do you do the particular integral? Let's go to the situation which we have right now. I want to show you the situation which we have right now, and I want to solve it, and I want you to tell me. I want the situation which we have right now. I'm going to go to the... Where is the situation which we have right now? The situation which we have right now is saying... Let me see. It says you have blah, blah, blah of z being equal to e to the xy plus 5xy. So the situation, let me explain to you the types of things you can meet in particular integral. You can meet exponential, you can meet 2, you can meet the second one, which will be polynomial, then 3, you can meet trig. So these are the types of things you can meet for particular integral. You hear me? What is it? Exponential, this e, then polynomial here, this polynomial here, and there is trig. You must know what to do for each of these situations. Here is another polynomial, of course. Here's another polynomial. So this other one is again a polynomial. So we need to know, how do we resolve polynomials when we are doing with this? I'll start by explaining, because we need to be able to quickly resolve and quickly get a solution. So what you're always going to do is you're going to take, for particular integral, you separate it. You're going to take this same thing here, but you're now putting it dividing, and you put it multiplying whatever is going to be on the other side. Then you start to resolve from there. Now, let's start by talking about exponential. For exponential, let's put here. Let's put 4 exponential. For x, put this, just put this statement, and it's gonna be very, very important for us. Put this in. Now, I want you to know that we already know from here that we had we didn't really see it because you didn't have to construct. But you must know that D is related to things to do with X, and D prime is related to things to do with Y. So when you're doing exponential, it is the easiest case, and remember I told you. So for X, what you're going to do is, wherever there is going to be D, you are going to go and take the number before X. In this case, it will be 2. Then for D prime, you just go and take the number before Y. In this case, it's 1. Then you are going to be able to start solving once you get to that situation. You hear me? For exponential, you are going to take the D, because you will always need something for D, something for D prime. Like these guys, these guys. For D here, it will be 2, which is, in this case, is 2. It will be the number before X. You don't change its sign. You don't make it negative or everything. For D is the number before X. Then D prime is the coefficient of Y. It is the number before Y. That is going to be your D prime. So you need D and you need D prime. If you have them, this is going to be for exponential. And you're going to use that. You're going to feed it into here. And it is going to help you to get a solution, right? Now, what about when you are going to have trig? What do you do when you're going to have trig stuff? When you're going to have trig, you really have to know exponential and trig. These are the main ones. For polynomial, it is going to solve itself. I'll show you how. For polynomial, it's going to solve itself. Don't worry about it. But for x, did you see what you do? D is the term before X. D prime is the term before Y. Don't change the signs. And work like that from there. You'll get to your solution and whatever. But there's one thing which you must know is that if you are going to put these, you're going to feed them into this thing, okay? And if you get it giving you an answer of 0, we'll tell you how to change. There's going to be a for all the situations we're learning with. If you feed in these values and you get an answer of 0, you're going to alter your equation a little bit and then feed them again, okay? But you must remember, for exponential, the rule is D is the number before X. D prime is the number before Y. You hear me? Good. Don't forget that. Now we're going to say now, what about for trig? For trig, it's completely different. I need you to know this. For trig is going to be like this. Put this for trig. This is going to be very important. D squared is equal to negative of the number before X. So it will be negative 2 squared. You always square it. So D squared is equal to, but the negative is outside, so it will never ever go anywhere. The negative is not going to be squared. It will be outside, so it will never ever go anywhere. Then D prime all squared is equal to negative, this is nice, eh? We don't have D. For trig, you don't have for D, you don't have for D prime, but you'll be knowing D squared and you'll be knowing D prime squared. D prime squared is going to be what? The number before Y, all squared, but there's a negative in front of it as well. So in here, the number before Y is 1, so it'll be negative of 1 squared. You put negative after squaring. Then you now say D by D prime. What will this be now? D by D. So we have 3. And if you look at the situation, they gave you easy because they gave us one where there's a D squared. They gave us one where there's a D by D prime and one where there's the D prime squared. So it's easy. Wow. Simple stuff. Because if they'd given you one where you didn't have such a situation, then you'd have to do a lot of altering. So here we have D squared for trig. We have D squared. We have D prime squared. It'll be the thing before Y, but put a negative and square it. Then you're going to have D by D prime is negative of, you now multiply those two together. So it'll be negative of 2 times 1. Okay, you multiply the one before x and the one before y, you put a negative in front of them. Then you multiply them together. Then you're going to be able to work. I know it's simple. Come on. For exponential, d will be the term before x, d prime will be the term before y. No changing of signs. For trig, d squared is negative the thing before x all squared. Then d prime all squared is negative, then the thing before y all squared. Then d by d prime is negative, then you multiply the thing before x and the thing before y. Then you're going to have your solution. That is what you now do for particular integral. So what we are now going to write, this is us writing now. Let's go ahead and let's see how we're going to do it. Then we can solve and you can see how easy it is. So it always is very easy. What you now do, you're going to say for particular integral. Now everybody can see here that if I'm doing this number 5a, on the other side I have two things. Here is an exponential, then here is a polynomial. Remember we said in this situation when you're doing, you do them individually. You do them individually. So what you're going to do, you'd say 1 over whatever your d was. So let's put the d which we had in this particular question. So you always will say 1 over. So it's going to be 1 over, let's put that d. What is that d going to be? It is going to be, the d is, it is d squared plus 7d d prime plus 12d prime squared. D squared plus 7d d prime plus 7d d prime plus 12d prime squared. Right? And this is multiplying what? So I want you to say, what you always do, you say particular integral number 1. Let's move this away. So it's going to be like this. We're going to say this is going to be particular integral number 1. Because there are two of them. So it's you're going to get two particular integrals. You add them to the complementary function. Nice and simple. So for my particular integral number 1, I would say, okay, this one was, we wanted to multiply what? We always go and we see, what do we want it to multiply? We wanted to multiply e to the 2x plus y. So this is going to multiply e to the 2x plus y. This is the one we have. So we are doing particular integral for the exponential. Now for the exponential, what do we know? D is going to be 2, then d prime is equal to the 1 before y, which is 1. You always have to write, depending on what you are solving. Are you doing the trig one or the whatever, the polynomial one, or this one? So here we do it like this. Then we're now going to say this is going to be equal to 1 over. For d, we are putting 2. So it's 2 squared plus 7 by d, which is 2 by d prime, which is 1. Then you're going to say plus 12 by d prime all squared, which is 12 by 1 squared. And this is going to multiply e to the 2x plus y. So what are we going to have now? 1 all over 2 squared is 4 plus 14 plus 12. And this is e to the 2x plus y. Can you see that? Then what are you going to have now? You're going to have it as 1 over 30. And this is e to the 2x plus y. There we go. Is it 30? 18 and 12? Yep. So here we have 1 over 30 e to the 2x plus y. That's the first particular integral. Then we're going to say particular integral number 2 is going to be 1 over the very same thing. You bring back that stuff which at d. It'll be what? D squared plus 7d d prime. So it's d squared plus 7d d prime plus 12d prime all squared. Now what is it multiplying? We're going to take the second function. What is that second function? It is 5xy. This is the second function. Can you see it? So it's going to multiply 5xy. So this is now a what? This is now a polynomial. Don't forget, I'm sure you can all see that. This is now a polynomial which we're trying to solve. We have done the multiplication for the other type and we have gotten it. Now we are trying to solve this polynomial, okay? We are trying to solve this polynomial. So we would now need to know how do we do it. So for polynomial, here is what you always do. and let's go step by step, and we try to get to the final solution, and then we'll see how it goes. We'll do some adjustments. For polynomial, all the time, you always factor out. Let me show you the tricks. These are tricks that you do in the first few steps. You factor out this guy who is the d form. You factor him out. So it's going to be 1 over here. You'd get d squared. Then you'd say 1 plus here, because you factor him out. When you factor something, it's like you're dividing by it. So it will be 7d prime over d squared. Then it'll be plus 12d prime squared over d squared. And this multiplies 5xy. And then what are we going to get here? It's like you're now just going to be simplifying. You're going to now say it'll be 1 over here, or instead of saying 1 over, sometimes what we do is we'll say this is going to be, you can keep this as 1 over d squared, but you will now have this 1 plus 7. Okay, this d will go into d squared, and they'll cancel, remain with the d. So 1 by 7 d prime over d, plus here you'd have your 12, and for my 12 I would have it as here. It'll be 12 d prime squared over d squared, and this is all going to be to the power of -1, and it is multiplying 5xy. Can you see this? Let me see my battery. The battery is going down way too fast. Introduce the brightness a bit. Okay, good. I think it's fine now. We continue. So what am I going to do? We say you're going to put your 1 over d squared here. Now when you put your 1 over d squared, you're just going to continue. So you see when there is a, wow, what was happening here? This was 1, and it becomes 1 plus this. What you can do is you can say it is going to be equal to 1 over d squared. Then I would say, since these ones have a common denominator, let me leave it as a common denominator, d and d prime, so that you can see how the sign will change. So this will actually become, even if I don't change the sign here, I can still change the sign outside. You see the sign which will be outside here. So what I could do was, I could have said it will be plus 7d prime minus 12d prime squared all over d squared. We divide everything to the -1, and it's 5x. Why did we say the negative? Because it's actually in the denominator. We can put it in the numerator, but we should put -1, because it was actually, this thing as it is was actually in the denominator. So that's why we are putting a -1 outside. That is why. But if you want to eliminate the -1, you can just change the sign here. That's a trick which you must know. So yeah, this is going to be 1 over d squared, and it will be now 1 minus, then you put this whole thing. So it's like you just change the sign. That's all you gotta do. You understand me? This was a plus, man. So it's going to be 1 minus, then you can now say 7d prime plus 12d prime squared all over d squared, multiplying 5xy. So now what you're going to do is you're going to put the negative. You hear me? When you put your negative, you have removed the thing, and you can put your negative. Then you start to simplify. Now there's this thing about simplifying. Let's go ahead and let's simplify. That I would want you to know is that if I'm going to simplify this, well, I already know. So it's going to be 1 over d squared. Then we're going to have 1 minus. In here, we know that the d will go into this 1, into d squared, you remain with the d. So it'll be 7d prime over d. Then it's going to be, if you are taking it as negative. Now what will be happening is, if I have this 12d prime, okay? If you're going to have this 12d prime, what will happen is the d prime and the d squared, it's like they cancel. You hear me? So you'll be having it as the d prime and the d, they'll cancel each other out completely. If I pull it out like that. And what you'd end up having is what? What you'd end up having is something like this. instead of the 12 and the d prime, because what you'd be doing is, if I were to look, d prime all squared is, I'm differentiating twice. Okay, it's like you'll be differentiating twice with respect to y. And if you differentiate twice with respect to y, you get nada, 0. So it's like it's going to disappear completely, and you'll be having something like this, and you'll be multiplying 5xy. Differentiating r twice with respect to it. Let's see now what would happen when I'm in this particular situation. I have a 5xy. Now this is where things get interesting. So it's like, just everybody will kind of just remember that these will cancel each other out to nothing. It's not a 0, it's not a 1, because if it was a 1 you'd have to add. It will cancel each other out to nothing, and then you can just continue. I'll confirm with you. I'd love to go to examples somewhere in your slides and go through some things, some parts, and confirm something that I always want you to see all the time. If I can go somewhere to the slides. But I know if you can go to your slides and check 2 examples, you look for 2 examples where you had your D, you'll probably see this, that I'm telling you that 9 times out of 10, okay, when you're dealing with this D, 9 times out of 10, then what is going to happen is you're going to have your D prime, your D and your whatever canceling each other out, and then you'd have a situation like what I'm saying. So what you do is you'd say, okay, for in here, let's continue. I would have, here's what I want you to now know when you start to integrate. To get rid of this d squared, this is the second derivative. To get rid of him, it's like you're integrating. So when you're trying to get rid of this d squared, in the steps that you're going to be doing, you are going to be integrating. That is the only way to get rid of that d squared. It is going to be integrating. And how you get rid of d prime, you also integrate. But when you integrate, when you're getting rid of d prime, it's like when you integrate it, it actually cancels out. So whenever, let's talk about it so you guys can see what I'm trying to say. Whenever I have a y like this, and I have this d prime in the numerator, it is going to cancel out any y. So if I expand, I will have 1 over d squared is actually going to multiply 5xy by 1 becomes 5xy. Minus, here you would be having 7. This d prime and this y will cancel for this situation here. So you end up having 7x over d. Okay? The d prime and the y always cancel. They neutralize each other all the time. Just always remember that. I told you that. They always neutralize each other. So now what you end up having is you now say this is going to be, how do I get, let's start by getting rid of this d. How do I get rid of this d? By integrating. So what do? I go to the x which I had. Here is the x which I have for here. Where the d is acting, it is acting here. What x do I have? An x. So what do? I integrate it. In other words, I increase this power, then divide by that new power. So I'll have 1 over d squared is going to be having 5xy, then minus. This becomes 7x squared all over 2. This becomes 7x squared over 2. So you'll be increasing, then you divide by that new power. Then that d, one of the d's gone. Now we continue. We want to get rid of this d squared. How do you get rid of the d squared? You are going to be increasing the power on x. So first it will become 1 over d. That means we integrate once. What do? You increase the power. On this x, what do you have? A 5x. It becomes 5x squared y all over 2. Minus, you come here, you increase the power again. It will be 7 over 2. It's multiplying. This x squared becomes now x to the 3 over 3. You increase the power, divide by that new power. So, which would actually say it would be 1 over d, which would be 5x squared y over 2. Then it will be minus 7x cubed over 6, like that. Then we integrate again now. This is going to be, we integrate d. What do? You look at the power of x. So for polynomials, there is nothing to cram. There is nothing where you substitute. You are looking at the power for x. So the power of x, you look at the power of x, sorry. Here it's an x squared, you increase it. So we are now going to say instead of 1 over d, it's gone. So now this becomes 5x to the 3y over, we divide by 3, it will be now 2 by 3, because there is now a 3 also. Minus this becomes 7x to the 4, over now this becomes 6 by 4. And you would end up having it as 5x cubed y over 6 minus 7x to the 4 over 24. Here's your solution. What is this? This is going to be particular integral. Is it number 1 or number 2? This is particular integral number 2. Now, once you have your particular integral number 2, that's the other one which we wanted to find, right? Then you can now just go ahead and find your z. Remember, here's what your z is. Z is going to be equal to complementary function plus particular integrals, which is going to be complementary function. We got them by knowing that d is m and d prime is 1. The complementary function here is the complementary function that we found. We are going to put these two solutions. Then we are going to add the things that we found in particular integral number 1 and particular integral number 2. And you are done, Mr. Engineer. You're done. So you say F1, it was x minus whatever. Then we had a plus F2, then it was x minus whatever. Then we added plus this other one. What is the other one? 1 over 30 e to the 2x plus y. So it'll be plus 1 over 30 e to the 2x plus y. Then it was plus, now we put this last one. 5x cubed y over 6 minus 7x to the 4 over 24. This whole thing is going to be your z, which is going to be the final solution. There's an F1 and an F2. Here it's going to be, for F1, it was y minus 3x, then here it is y minus 4x. So it is, sorry, why am I saying y minus 3x, then here it is y minus 4x. And here's the final solution for z for this particular situation. We can now go ahead now and do the other one. Okay? We can now go ahead and do the other situation. Should we go ahead and do it? Let's do the B. Let's do number 5B together. I know we can do it in no time. 5B, d squared plus dd prime minus 6d squared of z. D squared minus d prime plus 6d squared all of z. Okay? Or it's actually plus and minus. Cos 2x plus y plus 4x plus 7y. Cos 2x plus y plus 4x plus 7. What do we have? We have this x, this what is it? Trig. We have the trig, and we know what to do for trig. We are going to do a substitution, right? We have a trig, and then here we have a polynomial. Here we have a polynomial. Let's go ahead and let's solve. So what we are going to do, we would say, first of all, complementary function, please, ladies and gentlemen. For your complementary function, you're going to say, we go d squared plus d prime minus 6 d prime all squared of z be equal to 0. Now you're going to say again, you'd say here, let d equal to m and then d prime equal to 1. What are you trying to find here? You are trying to find your complementary function. Once you have found your complementary function, you can go ahead and after finding your complementary function, you can go ahead and find your particular integral. How nice and easy is this? Huh? Nice and easy. So we're going to say, here where there is d, we are now putting m. We would have m squared plus, we have d and d prime, it will be m by 1 minus 6 by 1 squared. We don't have to put our z. This is equal to 0. This is now the auxiliary equation which we have to solve. You can even get a cubic equation sometimes. I don't know why they didn't give us one where it was cubic. I would have loved to have you do one which is cubic just for the practice of it. Just for practice. I would have really, really loved that. Let me see how my battery is at. 245. Okay, we keep going. So this now becomes, you're going to have m squared plus m minus 6 be equal to 0. Can we find, yeah, we can see this is a minus 6, so you can find the solutions, the factorization, nice and easy. Minus 6, the factors of 6, 1 and 6, 2 and 3. And we can see that it's a minus 6, meaning that 1 and 6 are going to have different signs, 2 and 3 will have different signs, so that they give you a minus 6. So we look here, this is positive, so the bigger ones are positive, the smaller ones will be negative. So they have different signs. 6 minus 1, that's 5. 3 minus 2, that's 1, which is the number which is here. So I took this. So I take this. So it'll be m minus 2, then m plus 3 is equal to 0. Although I would love to have you always use the quadratic formula. It always works, maybe. So here you could have from here, let's use the quadratic formula. I would love to have you stick to one thing. I'm sorry for doing that. Those who can factorize, you factorize using the method you know. I will always use the quadratic formula for here. A is equal to 1, B is equal to 1, C is equal to minus 6. A is the number before m squared, which is 1. B is the number before m, which is 1. C is the constant, the last digit, and it's a minus 6. When you take a value, always take it with its sign. Do not forget that part. So now what you're going to have is you're going to now say b squared minus 4ac. This is equal to 1 squared minus 4 by 1 by negative 6, which is 1 minus becomes plus. 4 times 1, that's 4 by 6, that's 24. So it's 1 by 24, which is 25. So now we are going to say m is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a, which is equal to minus of b, that's minus of minus 1, plus or minus the square root of b squared minus 4ac, we got it as 25, all over 2a, which is 2 by 1. So which is minus of minus 1, that's 1, plus or minus the square root of 25 is 5 over 2. Here you get your m. So the two solutions for m will be m is equal to 1 plus 5 over 2, or you have your m2 being equal to 1 minus 5 over 2. You have your m1 being equal to 6 over 2. Your m1 is 3, okay? Then you have your m2 being equal to negative 4 over 2. Your m2 is equal to negative 2. So we have a negative 2 and we have a 3. There we go. Here are the things. Let's go. So what are we going to now put? Well, we have our m1 and we have our m2. So are they the same? No. So what is your complementary function? It is going to be f1. Then you say y, what is it? Plus 3x. Okay, we take this for x. Then we say plus f2, and it will be y. Then this is a negative 2, so y minus 2x. Here's your complementary function. Nice and easy. Y plus 3x and 1. Then now you are going to go next step, which is, what is your next step? Finding your particular integral. So for our particular integral, we do step by step by step, and we'll be solving until we get the solution which we need. Let's go ahead and let's solve. What did we have? Remember, for particular integral, you get it one by one. So first, rewrite the whole thing that you had. Let's rewrite. Where am I? I've gone to the wrong question. All right, here's the question. So I'm going to copy it and go and paste it. You will rewrite this whole question. You are now going to step number 2, which is going to be finding the particular integral. So you come down here and you are going to say, this is very simple, man. This is very, very simple. You cannot forget this, right? You can't forget this. Excuse me. So you're now going to take, we say particular integral number 1. We say 1 over this thing. So it's going to be this whole thing. You bring it back. 1 over d squared plus d prime minus 6d prime squared. This is going to be equal to, no, you don't say it is equal to. The P1 is the one which is equal to this by cos of 2x plus y. So we are first dealing with this one. We want to get the particular integral with respect to this one. Now, what are you doing? You are doing trig. For trig, what do we know? We know that d squared is equal to, you change the sign on the first, then you square. It will be negative of 2 squared. So we can say our d squared is actually negative of 4. Then we can have our d prime all squared being equal to, you negative, then you square the term before y. So it's negative of 1 squared. So we can say our d prime all squared is equal to negative 1. Then now we can get our d by d prime. It is equal to negative of, you multiply the things now, 2 by 1. So it's negative of 2 by 1. So which is equal to d by d prime is negative of 2. Now we just feed. This is so easy. You got a situation where you can just feed and get it one time. Huh? I know it's easy, right? You are enjoying yourself. Then I put the minus here. Let me go back. Give me a second. It's minus of my. Wait, what is my b? Oh, b is a minus 1. Wow, sorry. It should be a minus of 1 because b is a 1. So it will be minus 1 plus. So this would be minus 1 plus 5, which would actually be 4 over 2. And you'd get it as 2. Then here you get minus 1 minus 5 all over 2. Sorry for that, which you get a negative of 6 over 2, which you'd get it as a negative of 3. I have a watchdog, somebody who is making sure I'm doing correct stuff here. Thank you, Mr. Man. Thank you, big guy. He has helped us, eh? We found two great solutions. So it's 2x and minus 3x. So please go and adjust there. But the rest is correct. So we are just taken here on our A, B, and C. That is where we had made a mistake. But anyway, we are now going on to find the particular integral. So particular integral number 1 we are doing for this one, and we know what you do for this one. These are, look, these are conditions. We are not, these are conditions that you are told. You are told that these are the things that the table says. And I know you remember it better by looking like this. Because to try and cram the table, just to cram that, if it's it, because you only have exponential and this trig stuff. So you know that if it's a trig, then you're going to have d squared, d prime all squared, then d prime. Then if it's an exponential, you have d and then you have d prime. D is the number before x, d prime is the number before y. That is for exponential. You don't change them. For trig, you put a negative outside, then you say d squared is the negative outside, then you take the number before x and you square it. D prime, negative outside, you take the number before y and you square it. D by d prime, negative outside the number before x times the number before y. Wow. Shock. Let's keep going. This becomes 1 all over. What is my d squared? D squared, we got it here to be negative 4. So it'll be negative 4. Okay? Then we say plus d by d prime, we got it here. Wait, we got it here to be negative 2. So plus negative 2. Minus 6 by d prime all squared, we got it here to be negative 1. By negative 1. And here it will still be cos of 2x plus. Don't change the function that will be here. You are changing it to do what? You only change if it's a polynomial when you're integrating. Come on. Hey. Come on, people. Don't let me down. This now becomes equal to 1 over. This is minus 4 minus 2. That's minus 6. And this becomes plus 6. So it's actually minus 6 plus 6 of cos 2x plus y. And you're going to get it as 1 over 0 cos 2x plus y. So this is a situation. And when you substitute things and you get it as a 1 over 0, if you're going to substitute, you resolve like I have done here. You have seen we've resolved. If you get a 1 over 0, this is a situation that we talked about last time. And we said that if you're going to get a 1 over 0, what do you do when your denominator is 0? You multiply by x. Where? Numerator. Then what do you come back and do? You're going to come back and differentiate the denominator. But you'll be differentiating it with respect to who? You'll be differentiating it with respect to d. Don't forget that situation. You'll be now differentiating it with respect to d. I'm going to need to show you an example I want to try and show you an example of the small thing. You alter, then you try again these same values. The d squared will never change. D prime O squared will never change. D by D prime won't change. But now what you're going to do is you're going to have to differentiate. You hear me? Why are you differentiating? You say, why are we doing that? Because you got a zero in the denominator, Captain. So because you got a zero, you have to alter something. You have to alter something. And after altering that something, it won't be there again. So it's really that simple. So what are you going to do? We said you multiply the numerator by x. Then we said you differentiate the denominator. But when you're differentiating it, you're differentiating with respect to d. So if you have a d, we want to see a d. If you have a d cubed, we want to see a d squared. The powers should be going down, eh? Like that. So let's talk about it. So in here, what do I have? I'm going to rewrite it, and then I'm going to integrate it. So I can say that my particular integral number 1 is actually going to be, the top was a 1, we multiplied by x, so it becomes x over. Now we differentiate the bottom. This was a d squared. It becomes, you drop the power 2, you reduce it by 1, 2d, then plus. Now we are going to d by d prime. So now the next thing we are going to do is do the d by d prime. We do the d by d prime. We are doing the particular integral again. We are differentiating it. Why are we differentiating it? Because we got 0. Because we got 0 in the, it was not a negative 2o squared. It was a negative of 2 squared. So the negative should always be outside after squaring. Okay, so what we're now going to do is, let's quickly differentiate these things. Where was I? Oh, I was taking from here. I was saying, okay, yes, we are just differentiating our particular integral, guys. So now we're differentiating again. How do we differentiate again? We would say, let's differentiate. What do we have now here? If we're going to differentiate, I want you to know that if I am differentiating, as you're going to be differentiating all these things, you must know that you are differentiating the d's. You are not differentiating the d primes. The d primes are going to be constants. D primes are treated as constants. What you're actually differentiating, let me try to see if I can put a situation here so that we do an example. I wanted to find an example from one of your things. Your particular integral to the d prime. Okay, I couldn't find it. But I'm just saying, it doesn't matter. I'm just saying these are constants, so you treat it as a constant. You treat it like a number. So in this case, you differentiate the d becomes a 1, so that means you just remain with a d prime alone. D prime don't touch. You differentiate these. And then here you're going to have minus 6 by d prime all squared, so it's going to be, well, this whole thing is a constant, because c is a constant, d prime all squared is a constant. When you differentiate constants, you get nada, so this is going to be 0. So I actually have it ending here, d prime. This is just a d prime. And what is this going to be? Does it change the guy you're multiplying? No. It's never going to change? Yes. You just multiply the top and you differentiate the bottom. Then you're going to put this guy again. So you're going to put the guy which we had. It was cos of 2x plus y. That's what we have. Just cos of 2x plus y. Now, let's go ahead and let's do it. So let's put the things. What do we know now? So here we have a 2d. Then we have a d prime. What a situation. We have a 2d, then we have a d prime. So we now need to be able to replace these things. We now need to be able to replace, because we have a d and a d prime. We now need to be able to replace so that we can see what happens. 2d plus d prime. So here did we have a 2d? No, we have a d squared. Do we have, this is d prime all squared. We have a d by d prime. So we actually don't have a d. What do you do? Oh my gosh. Question mark. When I have a d, put a question mark, but I will find it for the particular integral. But please make sure you've done what I've done here. Multiply the top by x and differentiate the bottom, exactly like I've done. I know it's 100% correct, okay? The d and the d prime, we'll talk about them, just how to get it. But now the last would be, what about my particular integral number 2? Let's move on. We'll come back. This is going to be 4x. So my particular integral is 4x, so it's going to be 1 over all that stuff, and it is multiplying 4x. So it'll be 1 over, what do we have? D squared d prime minus 6d prime all squared. So it is d squared plus d prime minus 6d prime all squared. And this now multiplies 4x. Now, what is this? A polynomial, right? Okay, what do you do for polynomial? You factor out this. So it's like you just have your particular integral number 2. There are things that you now know that happen. Because this becomes, you factor out your d prime, it becomes d prime all squared. When it goes into this, it's a 1. Then you say plus, you can put everything else to be over. So it'll be d prime minus 6d prime all squared all over d squared. Okay, because it is outside and it is multiplying like that. And this will multiply 4x. Now we can, instead of putting it like this, we can put a negative 1 on it. So it'll be d squared multiplying 1 plus d prime minus 6d prime all squared over d squared. And this is to the negative 1 by 4x. Now we know when it's the negative 1, just change the sign here. So it becomes actually equal to d squared, and then here you have 1 minus d by d prime minus 6d prime all squared all over d squared. And it is multiplying 4x. Now we do know what normally happens. The d squared just disappears. Let's just say that in simple terms. So you actually have d squared, and you'd have 1 minus d by d prime over d squared, and this actually multiplies 4x, which will end up happening as d squared, and you'd have 1 minus d into d, 1 into d squared is a d. So it'll be d prime over d by 4x. Now, how do you remove a d prime? We know that a d prime eliminates y. It's like it divides by y. Let's kind of say that. So here it'll be equal to, oh, remember here, this is actually not a d squared. This is a 1 over. It should always remain as a 1 over because it was in the denominator. So it's a 1 over. This is a 1 over d squared. So what you actually have is 1 over d squared. Then you'd have 4x minus. What you should know is that this d prime, when you take it away, it cancels out a y. So in here we can say it brings in a y. So it'll be 4x over y by d. So it'll be 4x over d by 1 over y. I'll be tempted to say that. Then here you'll be having now, let's deal with this d squared. It'll be actually 1 over d squared. Then you'll be having 4x minus. In here you need to get rid of this d. So how do you get rid of this d? You increase the power divided by it. So it becomes 4x squared over 2 by 1 over y, which now becomes equal to 1 over d squared. Then it is 4x minus 2 into 2, 1, 2 into 4, 2, minus 2x squared multiplying 1 over y. Now what do? We integrate with respect to x to remove these d's. You end up having 1 over d. Then you go to this first x. What is it? It's an extra 1. You increase the power. 4x squared over 2 minus this becomes 2x3 over 3 multiplying 1 over y, which now becomes equal to 2 into 2, 1 into 4, it's 2. It's 1 over d multiplying L 2x squared. Oh my goodness. Am I a happy man? Yep. X cubed by 1 over y. Let's kind of put it like that. So what will I end up having now? I would have increase the power, please. 2x to the 3 over 3 minus 2/3, and we can say it is x to the 4 over 4. Then multiplying 1 over y. Wow, good stuff, man. This will end up being 2x cubed over 3 minus 2x4 over 12y. There we go. This is going to be our particular integral number 2. We go to the very last one, right? We go to the very last one, and let's see how it goes. Let's see how this one is. Okay, we go to the very last one. Everybody okay? We get our particular integral number 3 now. Okay? Particular integral number 3. Well, I could have been referring to some of your solutions and seeing how it goes. we'll see. To see how some of it was finished up. Well, let's have our particular integral number 3. So this is going to be equal to, for my particular integral number 3, I'll say 1 over the very same thing, d squared, is it plus 6 d dy d prime, something 12 d prime squared. I don't know. What did we have? D plus d prime minus 6d prime all squared. So it's plus d prime, then it's actually plus d prime, then minus 6d prime all squared. Then now what is it multiplying? The third thing. 7y. It is multiplying 7y. Well, the whole journey keeps going, and we can say that it'll just lead to 1 over d squared outside. Then here would say 1 plus d prime minus 6d prime squared over d squared. You know? And this to the negative 1 by 7y. Then you just have it as 1 over d squared. Then you'd have what? This becomes a minus. Did we change it for? It becomes 1 minus, and here you'd have d prime over d squared. You can just say that by 7y. Now we know when you are going to introduce this d prime, for it to go, it will cancel out a y. So we can say this will be 1 over d squared, and you'd have here 7y minus, in here it would be, the y should go, it will be just 7 over d squared, like that. Which now this is going to be, we eliminate the first d, we introduce an x, so it just becomes 7xy. Then we say minus, in here we introduce an x as well, so it just becomes 7x over, oh, this is actually over d, but not d squared, by the way, it's over d, 7x over d. And even if I get rid of this d, it should be equal to 1 over d, then you have 7xy minus, here it becomes 7x to the 2 over 2. You increase the power divided by the new power. So then it becomes now this 1 over d again will come, and we'll say this becomes now 7x to the 2y all over 2. Minus this now becomes 7x to the 3, and it's all over 6 now, because it will be, you divide by 3, which is now going to be 3 by 2, which will give 6. And that is what you have. Then you can now just write one big thing at the end. You can compare with your assignment drives and whatever, and do adjustments where you need to. This is going to be how you do this one, the main one. Simple. And you remember now, you just write your z to be equal to the cumulative frequency plus the particular integral number 1 plus particular integral number 2 plus particular integral number 3. You just go and take all of them, you put in this, and you are done. That's how you solve this one. Surely you will be able to do it. Nice and easy, right? Nice and easy. So what are you left with? You're now left with using the idea of separation of variables in partial derivatives, and then also not only the idea of separation of variables, we are going to have the idea of separation of variables in partial derivatives, but we will also have now not only that, but we'll also have the idea of direct integration. We want to put the idea of direct integration, and yep, this is going to be, let's see how it goes. Right. Newman method. So for this last one, everybody can do this. Find the cumulative, the complementary function, and then find the particular integral. It's not hard, is it? You combine with those 4 you did, and this one, wow, you're good. You're just left with direct integration and this, and then the power series. And then you could say everything to do with test 1 and to do with test 2, you're done. Which is really amazing, right? So Let me eliminate all the things we don't need right now. Small stuff, simple stuff, almost done. All right. Look at the other things. How easy is this? Solve here by direct integration, then separation of variables, then that'll be another 22 marks. Look at that, separation of variables. Then you have also this one here, verify. I'll teach you. It's a very simple one. To the one which says you just differentiate. Then you have your power series. You are done. Then you have your power series and you're done. How easy is this stuff? This has to be the easiest, right? So let's see. Let's do this by direct integration by partial, and then this one to verify. Let's finish it up. Let's do these ones. And then we will do the power series. What you should remember on them. And then you'll be knowing that everything to do with the test 1 and test 2 you are good. So you'll be fine. Let's see. What is it going to say now? Direct integration versus separation of variables. Let's do separation of variables. Remember, this one is different from that. You can actually see that this is a partial derivative. This is not a derivative. It's a partial derivative. We've just finished this one where we were doing where there was a d and whatever, and we had 3 variables. So it's part of the ones where we're doing partial derivatives. And then here we have one where it is actually a partial derivative. Everybody can see that this is a del. Means when you're only differentiating with respect to one variable, you'll be having many, you ignore the others. That's a partial derivative. So if they're saying separation of variables and they put a partial derivative, it is not the same as the separation of variables we did there. That other separation of variables, we put the things with dy on the left and the x and all the things for dx on the right. But in this one, that is not the case. That is not the case. That is not what we do for this one. You say, what? Yeah. So what do we do for this one? Well, for this one, what you're going to do is you are going to use a different concept. You're going to create a function that we call it a tentative solution or something. Then we work with that. So it's like you create a function which is by looking at what are the things that I have here. I'm differentiating u with respect to what? To t. And I'm differentiating u with respect to what? To x. So I'm going to have u being equal to a function of x and t, because it is going to be differentiated with respect to x and it is going to be differentiated with respect to t. I don't know if you can understand me there. So you're going to have your u, and your u is going to be a function of x and t. Once you have it like that, then you're going to start integrating. That is how you're going to always work. You're now going to start integrating the partial derivatives. And when you get the partial derivatives, you're going to feed them into something very long. And you feed in your solutions, then you're going to see what works. I'm going to show you what to do and what not to do. Something that is going to be, I think, very, very important for you. Should we do it? Good. So here, we just do it. So let's put the partial derivative. It's simple. This one is very short. You can even look at the marks. It's only 8 marks. So for partial derivatives, you just look at what were the partial derivatives you had. You create a function which depends on those two partial derivatives. And then from there, you start working, you start working, you start working. Yeah, that's more like it. Come on, guys. Come on. Then we're going to I'll show you. We create a solution. We make them equal. You already, when you get them like this, let me see, equal to each other, that's nice and makes it easy. When you get them not equal to each other, you should make them equal to each other. When you make them equal to each other, then you are going to find this thing, then you're going to find this thing, then you're going to make it equal to some weird constant like k or something. Then we're going to find that k. When we find that k, what that they are both equal to, then we're going to equate them to each other, and we're going to now put it, at the end we'll make them multiply each other. Sorry, we'll make them, because we'll use that to find the x and the t. You understand? Let's go and let's see what I mean, because you have to find the x and the t, which in most cases you'll be having your dx. So if I have my dx and I want my x, let's see how we're going to actually do it. So let's see how it's going to be. We would say, let me call it del u del t k del u del 2u del x squared. So it's del u del t is equal to k del 2u del x squared, I think. Was it an x? Yes. And then we'll talk about it. So here, they didn't even give me conditions. Sometimes they'll give you conditions. And conditions, when you are given, you are going to put them at the end when you're given conditions. Let's see what you do here. I have this. Anyway, I would say it is with respect to t, with respect to x. So I'll say let u, this one which I'm differentiating at the top, be a function of both x and t. Which means if I now say, what is del u del t? That means I'm only differentiating with respect to t. So the t is the only one that's differentiated. So it's xt prime t. Then I'll say, what about del u del x? I'm differentiating with respect to x. So that means t is a constant. I only differentiate the x. It becomes x prime times t. What about del 2u then del x squared? Because we want the second derivative. It'll be now x prime prime times t. Well, not even a problem. What did this thing say? It said that, let's go back to see where it said. It said that you have del u be equal to k, whatever. So let's put that. What is my del u del t? Here, it's xt prime. So I can say xt prime is equal to k multiplying del 2u del x squared, which is multiplying x prime prime times t. Now, all we like to do is we like to take the things that are with x to one side, the things that are with t to one side, and we like to put the derivatives on top. So t derivative is on top on the left. So that means we take t itself to the left. So it's t prime over t. This is equal to k x prime prime over x. Don't forget that. Then now, what are we going to have? We continue. We'd now say, okay, let's since here there was a k, it changes a lot of things. But let's just make it. Let's just make them be these two, since they were already equal to each other. Let them be equal to some other value called a or something. So now what you're going to have is you're going to say, well, let's put it. What do you have? You are having t prime over t, right? And what is this going to be? If I say t prime over t, don't forget, I can say, let's change the t prime. What is it? I'll say, instead of t prime, I'll say 1 over t by, what is t prime? It is del t, del, it's like you're differentiating. Del t with respect to t, you get t prime. Let's kind of say that. That's how we always do it. And this is going to be equal to k. Let's do this x. It'll be what? Del of, if I do the k, I bring it out. Instead of writing x, it'll be del 2x over del x by this 1 over x. Now, what do you do when it's like this? This is what you'll be having. What should you always do? Huh? If I have, let's make it be equal to a. Let's do one at a time. Because we've made them both equal to a. Let's make it be equal to a. So I'll now say 1 over t dt is equal to a d small t, which means if I actually integrate 1 over t with respect to big T, it should give me the integral of a with respect to small t. What will I have here? Integral of 1 over something is just ln of that something. So it's ln t. This is equal to, this becomes at. So ln t will be equal to at. I don't know if you can see that. But you should always also put your constant of integration, by the way, so that you can do it. I don't know if you can see me when I do that. Now, anyway, if you take t, let's take t, what will it be? It will, t becomes e to that at plus c1, like that. This is going to be it. And if you wanted it to be one thing, you'd have it as what? T is equal to e to the at times e to the c1. That's what you'll be having. And e to the c1, you can create a new value for it. They'll say t is equal to e to the at by b. Something like that. Which you could say t is equal to b e to the at. Now we need to work on this one now. Here. This. What are we going to work on it? We're going to work on it until we find x. Because what we are interested in finding is what? We are interested in finding x. Let's put it. So what we are going to put is frozen. Well, here it is showing. Refresh. Okay, so we continue. We also have this being equal to a. So we now take this. So we are now going to say kx dash dash over x is equal to a. So you're now going to say kx dash dash over x is equal to a, which you change this one to be k by here. We remember we are now changing our x dash dash dash. What will it be? Just like here we changed it when we had our t, right? We changed it. But here what would it be? We would just say k multiplying 1 over x, which you can say k over x. This dx, whatever, it will be dx, d2x, then dx squared. This is equal to a. So we can say now k over x, the second derivative, d2x, is equal to a dx squared. Kind of something like this. Well, integral of k over x second derivative is equal to the integral of a dx squared. I don't know if this actually does make sense. It looks very weird. Because we have the second derivative. So, well, I this would have to be two steps surely. So let's do this. Let's do double integrals. Let's see if we do double integrals. So just so that we remove the del x. So this becomes k is outside. You have the integral. You can put k outside for both. You start with 1 over x d squared x is equal to the double integral of a with respect to x squared. So anyway, this is with respect to big X. So I should say big X. 1 over big X with respect to, this is equal to with respect to small x. So what will I have here? I would have k by ln x, the integral of ln big X with respect to big X. This is equal to the integral of ax with respect to x, like that. Then now I'll have k. Then now I'm trying to integrate this ln x. There used to be, you can find the one where they'll give you a big thing, which was the solution of the integral of ln x, where you then get it as this would be now the integral of this. It'll be ax squared over 2. Then you say plus some c2 there, and we can have a lot. So you'd have found the integral of ln x, such that, what is the integral of this? You found this is the solution. Huh? Where is it at? No, it could be. Because it then results. Give me a minute. Okay, here. This one, the first one, we got it, right? BE to the AT. Then the second one, you change it to an equation. You see that? You didn't mark it, did you? That's the part you got wrong. But when you came here, you actually did continue to mark it. Did you get the marks for that part? Either way. Okay, he did make an equation. This one where you have the second derivative is a tricky one. But anyway, you can keep this one where you have the first derivative. You'd need to do the second derivative. Is this the very first question which I've done? Where they did it? Okay, this second derivative thing is going to be a problem. But all you'd have to do was to find for this second derivative. Then you'd now go back where you said u is equal to xt. Then you multiply the answer for x by the answer for t. I don't know the way some of your drives were writing. It's not very nice and something you can follow. But you just look for the question. You'd come, then you'd multiply the value of x by the value of t, and then you can have your u, because you had said u was equal to x by t. But remember, what you would have done is you would have done this step, very, very important step. Can you see? Where you found these two, then you make them equal because they were already equal anyway. Then you make sure that your t prime is on top, so you take these others. Then your x prime is on top, then you have it. Then now what you're going to have, you take this and make it equal to a constant. Then you separate this 1 over t outside. Then you change this t prime to be dt with respect to small t, and you integrate. You first take small t to the other side, then you can integrate both things, and then you can have something. Well, you can go ahead and it takes you all the way to this one. Then you'd have a solution for t. Now you need a solution for x because u is x by t. You need a solution for x, which I'm seeing some people use equations and they would find solutions and find the value of x from there to say x will be equal to e to the whatever from your solutions that you would have found. Maybe like from here where you had kx prime prime being equal to ax. So it's like you ended up saying ax, no, kx prime prime minus ax is equal to 0. Then he went ahead and solved. So anyway, we know that this is our a and this is our b. Our c is 0. So you say b squared minus 4ac. This is going to be my b, that's negative of a, that's your b, all squared minus 4 by a, which is by k, by c, which is by 0, which is just negative a all squared is just an a squared. That's your b squared minus 4ac. So you can now say that your solutions, if you wanted m, is equal to minus of b, which is minus of negative a, then plus or minus the square root of b squared minus 4ac, which is square root of a squared, or over 2 by a, which is 2 by k. Then you're going to have it as m is equal to minus minus is a, plus or minus square root of a squared is another a, or over 2k. Wow, this is crazy. So you'd have m be equal to a plus a, that's 2a over 2k, or you can have m to be equal to a minus a, that's 0 over 2k. So you'd have it as m is equal to a over k, or you have m is equal to a over k, or you could have m2 be equal to 0. So you find these solutions. Let's see what they did. Solutions for, we got them as plus or minus that. No, you didn't even do that. His situation was when he had it in this form, kx lambda whatever, then you introduce here x lambda lambda minus lambda. This becomes m squared, but there was supposed to be an m here. That's where you got in trouble. Can you see that? Hmm? Because where did he put this one? But he is correct because the x bar is the one which becomes an m. X bar, yes, that becomes the x. Then the normal x becomes a constant. Oh no, so small adjustment. I've been looking at small adjustment. We keep going. Here we have x bar, so it's like if I come and I say let's change it so that you guys can actually do it correct. We would say here, if I say let x bar be m squared, that means that x bar will be my m, and that means that x is just nothing. Yes, x is going to be a constant. So it's like x is going to be, if we can say it's going to be whatever the constant is, we'll leave it to that. So this is going to be a constant. So what we'd be doing is we'd actually have it say, it would be saying, if it was it would be saying km squared minus, we could just say it is minus ax. We don't change it. And as ax is equal to 0. We could actually have said that this is going to be nothing, but you'd have it as 2m. So you'd say now, what would it be now? This is going to be my a, this is going to be my c. So b squared minus 4ac is actually 0 squared minus 4 by a by k by c, that is negative a. So it would be actually negative, it would be 4ak. So it's 4ak. That's going to be my b squared minus 4ac. So we'd actually now go ahead and say minus b, that's your m, minus b plus or minus the square root of b squared minus 4ac all over 2a, which is going to be 0, that's b. Then you say plus or minus the square root of 4ak all over 2 by a, which is 2 by k. which is going to be plus or minus of 2 root a k over 2k. Kind of stuff like that. You'd get your solutions for m, which there'll be two different real number solutions. So like you'd have m being equal to 2 root a k. Okay, the 2's and the 2 will cancel. So we can say m will be equal to the root of a k over k. Or you could have m2 being equal to negative the root of a k over k. Then that means when you're finding your solution, you'd say x will be equal to, since there are two solutions that are different, we know what happens. It will be a e to the m1x, which is here, root a k over k x, plus b e to the m2x, which is negative root a k over k of x. This is the thing which you then multiply by your t. Here's my t, and here's my x. So you can now say u is equal to xt. You multiply this x by this t, b e a t, then you can get your u. Kind of like that. That's what you do. You change this x. When there is a second derivative, change it to an equation. Just do it as an equation. Make it equal to 0. Solve. And then you'll be having your x. Simple, right? This will be the solution. And for direct integration, let's go ahead and let's see where it's going to be now. By the way, if you had conditions, you'd only put after you now get to this point where you use xt. Then you can put your conditions. Now you can see the one for, wait, which one? For direct integration, you'll be just integrating until you get to the value where you want. But when you integrate, you should just put the constants nicely. It's very simple. And after this one, we'll do the one where it says prove. And after you can prove, then you take a small break and we do Frobenius and the power series. Okay, by the way, if this was just an x, if this was not a second derivative, like most situations, if it was just the first derivative, then what you were going to do was you would just still do the same thing. It was going to be x prime over x, okay? And what you would have done, you would have made it equal to some value k, and you would have said that 1 over x multiplying the derivative of big X over the derivative of small x is equal to a. Then you take small x to the other side, you'd have 1 over big X times the derivative of big X is equal to a by the derivative of small x. Then you'd integrate both sides. You'd integrate 1 over big X, the derivative of big X is equal to integral of a times the derivative of small x. Then this would just become ln big X is equal to, in here you'd get it as ax or something, and you take from there. Okay? It'll be like that, and you'd be solving. So, but because it's an x squared, everything changes. So now let's put the second derivative is 8e to the y sine 2x. Del u del x del 8e y sine 2x, something like that. Yes, then we have these conditions. Y is 0, del u del x is sine x. Then, and x by whatever. Y is 0, del u del x is sine x. So let's just quickly do it. This is a joke. So what you're going to do, you start by this, you have this, then you're going to introduce integrals both sides. Now what you're going to do is, you always remove. You start from this going vice versa. Okay, so you'll be integrating like that, going vice versa. So if I'm starting like that, you integrate going vice versa. Do not forget. And this is del x, then del y. So I'm going to integrate del u, del x, del y. I'm going to integrate with respect to only y, which is the last one, which is this one, the second one. This is going to be, I have to integrate the other side again, which is 8e to the y sine 2x. I integrate with respect to y again. Now the rule is just for partial derivative of partial integration. The rule will be just when you are going to do one, you keep the other as a constant. When you do the other, you keep the other as a constant. Simple like this. So if I'm integrating here, that means what happens? The del y will go, and I'll end up having del u del x only. This is going to be equal to the integral of 8e to the y. But because this is going to be a constant, and it's multiplying, constants that multiply are taken out. They never will go anyway. So it'll be sine 2x, and it'll be the integral of 8e to the y, and I'm integrating with respect to y. So the x is a constant, so I threw it out. How simple is that? I know it's very simple. Huh? Wait, what is my margin? Woo! 10%. Come on. This thing is a hater, right? So now it's going to be now our del u del x. It's a hater. Sine 2x. Let's do integration. 8 should also come out. It's also a constant, so it'll be 8 sine 2x. It thinks we won't see him. It'll be now the integral of e to the y with respect to y. Now when you integrate e to the y, it's like when you differentiate it. When you differentiate e to the y, it stays as a to the y. When you integrate e to the y, it also stays as e to the y. So, but because you have integrated with respect to y, you are treating x as your constant. So that means the constant of integration will be a function in terms of x, because we are treating x as the constant. So here you're going to have it. So you're going to say del u del x will be equal to 8e to the y sine 2x plus f of x. So now we're going to have, we integrate the del u del x. We integrate with respect to x, and this is equal to, now everything with y, jump out. Oh wait, first, before we integrate again, we need to find this f of x. So we go and take the conditions. Y is 0, del u del x is sine x. So we are now going to put it, we're going to say let y be equal to 0, and let del u del x be equal to sine x. So that means wherever I'm seeing del u del x, I'm putting what? Sine x is equal to 8e to the y, which is 8e to the 0, times sine 2x plus f of x. I have to find this f of x. So it's going to be sine x is equal to, any number to the power of 0 is 1. So it's 8 by e to the 0, which is 1, by sine 2x plus f of x. So I can say sine x is equal to 8 sine 2x plus f of x. Now take it to the other side. Sine x minus 8 sine 2x is equal to f of x. There we go. This is going to be our f of x. So we actually found here Mr. f of x. We are now going to rewrite. We would say now del u del x is actually going to be equal to, del u del x is actually going to be equal to 8e to the y. Then we have sine 2x, so it is sine 2x. Then we now say plus sine x minus 8 sine 2x. This is fantastic. We integrate now. Of course we're going to integrate with respect to x, and you have your u is equal to the integral of this whole animal with respect to x. 8e to the y sine 2x plus sine of x minus 8 sine of 2x, and we are integrating this whole thing with respect to x, so del x. That is why the u is only now u. Then now we are going to say, what is this going to be equal to? In here we treat this as a constant, so you have 8e to the y. Then we integrate sine 2x. If you want to integrate the sine and the cos, sorry for that. If you want to integrate sine and cos, you should know the derivatives. The derivative of sine x is cos x. The derivative of cos x is negative sine x. So I'm integrating, which means I'm going backwards. So integral of sine gives me cos if it is negative sine. But here it is positive sine, so it will give you negative cos. So it's negative cos 2x. But we should then divide by the derivative of the inside. What's the derivative of 2x? 2. So we then divide by 2. So this is multiplying because this constant had been out. Then we now say plus the integral again of sine x is just negative cos x. You know from the table. Negative sign gives you positive cos. So positive sign gives you negative cos. So it's now minus, here there is an 8 which is a constant. Sine 2x again, it should give us negative cos 2x. But then we divide by the derivative of the inside, which is by 2. Then we can put our constant of integration c. But because we have differentiated with respect to x, our constant of integration will be a function of y. It will be a function of I. Because we are integrating with respect to x, so the y's are the constants. So here we are going to have it as 2 into 2, 1 into 8, that's 4. So it becomes negative 4e to the y cos 2x minus cos x. Minus becomes plus 2 into 2, 1 into 4, that's 4. So it becomes plus 4 cos 2x plus f of y. This becomes my u. Now let's go ahead and get the other constants we are done. So direct integration, u as well, we are done with u. So, oh my word, can you believe we are done with all differential equations? Now it is all just power series. Man. Because now you're about to find the u and you're done. This is direct integration. It's like a joke. It's like playing. Now the only thing you're left with is power series. But we want to see that one which says proofs. The one which says proof, we actually use differentiation. It's not integration. So the question which says proof is very easy. We have to get it. Then we'll obviously have the power series. And if you do part 1 and part 2 thoroughly and you're good at all these things, you're done, man. You're done. It's time up. It's harder. It's not too much. You can actually pass. Let's take the other conditions. What were the other conditions? X is pi over 2, u is 2y squared. Let x be equal to pi over 2, u be equal to 2y squared. 2y squared is equal to negative, it's negative 4e to the y cos of 2 by pi over 2 minus cos pi over 2 plus 4 cos 2 by pi over 2 plus f of y. Thank you so much for paying attention to this matter. 2y squared is equal to negative 4e to the y. This cancels, it becomes cos pi minus cos pi over 2 plus 4 cos pi, because the 2 and the 2 cancel, plus f of y. What is cos 90? It's 0. So anyway, we would have it as 2y squared minus 4e to the y by 0 minus, no, it's actually cos 90 is the one which is 0. Cos pi is cos 1h, so it's cos 1a. That's negative 1. So by negative 1 minus 0 plus 4 by cos pi, which is by negative 1 plus f of y, which now becomes 2y squared is equal to negative becomes, it's now equal to 4e to the y. Then minus 4, then plus f of y. Now we take these things to the other side. We have 2y squared minus 4e to the y plus 4 is equal to f of y. Ready? Yeah. And what is that? Just a constant. So let's put our u. We just rewrite our u and we would be done. So you'd now say, oh, rewrite your u. It becomes now u is equal to negative 4e to the y cos 2x minus cos x plus 4 cos 2x plus your f of y, f in y, f of y, whatever, It is plus 2y squared minus 4e to the y plus 4. This becomes the whole solution, and that's your u. And you're done. And you're done. Now let's do the one which says proving. Let's do the one which says prove, and let's prove the one which says prove. Where's the one which says prove? Which one? Verify. When you have u and verify this. So anyway, I'm going to verify right here because I think there's enough space. So you have your u. You write your u is equal to e to the negative y by cos x. Now find these. Then you are just going to add them and show that they'll actually give you 0. So you say, let's differentiate here. We are differentiating with respect to x 2 times. Here we are differentiating with respect to y 2 times. So remember, when you differentiate with respect to the other one is a constant. Simple. Del u, del x. We're differentiating with respect to x, so y is a constant. It doesn't change. The derivative of cos x is negative sine x. Then it actually becomes del u, del x is equal to negative of e to the negative y sine x. Then we can now say del 2u del x squared is now equal to negative e to the negative y. Is a constant again. We differentiate sine, we get cos x. So it's just by cos x. So you don't have to put it in bracket actually. So it's just going to be del 2u del x squared is equal to negative e to the negative y. Let me make sure all the things are closed because it's raining, so there's a bit of noise outside. Man. And my gadget's battery is low, so I'm going to have to disconnect the microphone, which means if I use the speakers on it, you're going to really be getting the noise of the rain, which is crazy. So this is going to be cos x. Let's just put it. Then now let's quickly do for del 2u del y squared. You have u is equal to e to the negative y cos x. Now we get our del u del y. It's differentiation. What is it? This, you are differentiating e to the negative y. It comes back as it is. Then you multiply. Let's just quickly do it. When there is a negative, you differentiate that power. Then you bring it back as it is when you multiply. So the derivative of negative y is a negative 1. Then it will be e to the negative y. It comes back as it is. Cos x. Cos x won't go anyway. Then we do the second derivative. Del 2u del x squared. It is now going to be equal to, again, negative. So negative now, it's negative of negative, then of e to the negative y. It comes back. Then cos x will remain. Cos x is just a constant. So it becomes negative, becomes e to the negative y. Cos x. It goes back where it was. So now let's add them. So we can say negative e to the negative y cos x plus this one, which is e to the negative y cos x. We can say this is equal to 0. Is that true? Let's continue. Yes, this is equal to 0, so you can say it's actually true, which means you have proved. You just proved by differentiating. Good. Great stuff. You prove by differentiation. Because you can see that this is negative of e to the negative y, then this is the positive. So the negative and the positive will cancel, and you get a 0. So it's actually very true. That's it. You have done the proof, the verifying. Now you are left with the Frobenius and the other one, and you're done. Done. The two power series, Frobenius and his friend. Let me put my thing on the charger. Give me a sec. We'll break a bit, and then I'll do Frobenius, then stop. Okay? You hear me? 1, 2, 1, 2. Let me finish this. Hope you had a good short break. Let's finish it, eh? I kind of boosted my device a bit, so I think it's charged. Which questions? I want to do power series method in Frobenius. So anyway, let's quickly put that because that's what I feel like that's what you need to know. Let me erase first. Let me erase first, and let's see how it goes. Right. I don't know how many pages it's going to take me, but let's just put. Here's the small difference between Frobenius and the other one. The major difference is when they say do Frobenius and they say do, it's your y. Okay, so for the general power series, what you must go in remembering is your y. The other stages you do as you write. Then for Frobenius, what you must also remember is the y for Frobenius. All right, so what is the y for the general power series method? Then for Frobenius, the y is going to be like this. The y is going to be, the y is going to be in here. We say a0, then you can say x to the power c. Then you can say plus a1, it's x to the power c plus 1. Plus a2, x to the power c plus 2. These are powers in Frobenius. It keeps going until it gets to ar, x to the power of c plus r. Then for in here, it would be a1 x1 plus a2 x2 plus a3 x3. So it starts with a0, a1 plus, it keeps going, plus an xn. These are not powers. These are not powers, and we have nothing called c. So try to remember these. These are the terms. These are what you're going to write when you get into the thing. Once you have written this, you can now go ahead and do the other steps, whatever which you may be required to do. So let's see what the question in here was saying. We've got this, and we're supposed to do our power series and use Frobenius to find the power series of the following. Frobenius was going to be for this one. So basically, anyway, if we have the y, that means we can easily get this y prime prime and this y prime. So what we'll do, we have y. So we are going to get y prime, then we are going to get y prime prime. Now once we have it, we'll get this x squared plus 1 multiplying y prime prime. We have negative 4x multiplying y prime. Then we have 6 multiplying y. We're going to have this, and that'll be for the general power series. You understand? That'll be for the general power series. And we are going to put the solutions and find out what this is going to be. And that's how we do it. So we're going to end up putting the solutions. Let's do it. It shouldn't take us time, huh? It shouldn't take us time. So we have y, we're starting with the power series. So let's find y prime prime, y prime. Then we can do the rest. This is my y. I'm starting with the power series. So I'll just go y is equal to a0 plus, this is me writing. What is going on? Hmm? No. So it's going to be plus a1 x1 plus a2 x2 plus a3 x3 plus blah 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 plus an xn. Y prime will be a0 will go, then in here when you differentiate, it's like you are just going to be differentiating, okay? And that's how you get your y prime. Then to get your y prime prime, sorry, and to get your y prime prime, you just differentiate again, you differentiate again. It's kind of how it's going to be as you go along, okay? Remember to do that. Please remember to do that for your general power series. You're going to have my general power series. It's going to be the same thing. Now, if you're going to see in your slides, you see them also in some of the situations. I think if you check for the power series which your lecturer uses, he likes to do, instead of your a1, he would say plus ax plus a, that's a1, plus a2x squared plus a3x cubed plus a4x to the 4. You can also do that, plus blah blah anx to the n. A. So this will be now for your y prime. A's derivative of a0 will go, plus this one, it just becomes a1, plus in here you drop the power obviously, so it becomes 2a2, then you reduce it by 1, it becomes x to the 1, then plus here it becomes 3a3, but this becomes x squared, plus this becomes 4a4, but it becomes x to the 3. So this is what it will be. So it will be 4a4, but it becomes x to the 3, plus dot dot dot, it becomes n a of n, so it's n a n, then x is now to the n minus 1. That's where it goes. Then we can get y prime prime, which will be now a prime will go, it will be now just here, you differentiate, it becomes 2a2, plus in here it becomes 6a cubed x, plus in here you drop the power, it becomes 12a to the 4, it becomes x squared, plus keeps going, then it becomes n plus n by n minus 1, then a n x to the n minus 2. Anyway, that's how it keeps going, and you'll be having it like that. So now what we are going to do is now get the other things which we had. So what did we actually have in the power series? We had a 6y, we had a 4xy prime, we had an x squared plus 1 multiplying y prime prime. Negative 4x multiplies y prime. 6y is going to be 6 by that. It will be 6 by a0 plus 6 by a1x by 6 by a2x squared by 6 by a3x cubed by, keeps going, 6 by anx to the n. Then this one is going to be what? X squared plus, no, minus 4x of y prime. So it's going to be minus, you say minus 4x of y prime is actually minus 4a1, then minus 8a2x minus 12a3x squared minus 16a4x cubed plus dash 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 dash, it keeps going. If you want, you can put all the way, but you can stop. There we are going to have now y prime prime. It is, I think, 1 minus x squared is multiplying it, something like that. X squared plus 1. So you now say x squared plus 1 is now multiplying y prime prime. This is going to be, here it will be 2 multiplying x squared plus 1 multiplying a2 plus, in here, if you want, you can say it'll be 2a2 multiplying x squared plus 1 plus 6a cubed x multiplying x squared plus 1 plus 12a to the 4 x squared multiplying x squared plus 1. This goes like that. Then now you can put it you can put it inside that one thing which said this whole thing was equal to 0. So you can say this is all equal to 0. All these, this is all equal to 0. Okay. Now, what you'll be doing is if it is equal to 0, this whole thing, you now start to take like terms and they should be equal to 0. So if we take the things on the right hand side, obviously, the things for a0, they must be equal to 0. Okay. If we are saying the things, no, it's not the things for a0. We are taking the things without an x, which is the constants. So the constants should be equal to 0. So in this case, we would say 6a0 minus 4a1 is equal to 0. So you would have 6a0 be equal to 4a1, which means you'd have a0 be equal to 4 over 6a1. You see? Then you group the things before x now. You group the things before x, you group the things before x squared, and that is kind of what you do, okay? In here, you can try to expand it to make it more clear. It's still fine if you have 2a2 x squared plus 2a2 plus 6. Yeah, it becomes wow. Anyway, you can leave it like that, but you have what? Wow, this is a nice one where you have something like x squared plus 1 multiplying your thing. It changes everything. It definitely, I don't know if you can hear me, it definitely changes everything. And the calculation, was this was the assignment? Let's see.
But the part there, x squared plus 1.
Yeah, where you're now just starting to make everything equal to 0. So here we had our 6a0 minus 4a1. Where was it? Is equal to 0. That's what we had. So it's 6 plus 2a2. This one. When you multiply by x squared plus 1, why did you get these marks? Oh. Yeah, that's what we were talking about. So, but then... got a point. But now the thing is, a1 oh, here when we multiplied, we should also multiply by this x. So this could have become a1x, this one x squared, this one x cubed. Then this is actually the power 4. Which means that for the constants we don't have this one. We actually, for the constants, will be having the same thing, which would be, if we expand this one, if we expand, we could expand, doesn't matter. We would have this plus 2a2, then here we would have said, it would have been by 6a3 x cubed plus 6a3x plus 12a4 x to the 4 plus 12a4 x squared. Like they'll be like that. So it's like you multiply by this, then by 1, by this, then by 1. So what you'd actually see is the constants are this one. Only, it's the only one with no x, and it meets with a0. So it's like you'd be saying the constants should be. So 6a0 plus 2a2 is equal to 0. Which means that 6a0 is equal to negative 2a2. Which means that a0 is equal to negative 2 over 6a2. It means that a0 is equal to negative 1/3 a2. if that's another way to write it. In terms of writing it this way, you could have taken the 3z to say negative 3a0 is equal to a2. It's still fine. A2 negative 3a0. It's just rewriting the very same thing. Okay. Now you take the things for x, which will be this one, and who else has x in the expanded one?
6a1 minus 4a1.
It's this one, 6a3. It's the other thing with an x. So the thing with an x, you get it here, minus 4a1, then plus 6a3. You understand? Is that what they were writing? For
They
x?
replaced in certain parts.
Yes.
What else?
From a3 to put no, what the a2, what it meant, right? Because the things which we are going to have with an x are a1 and a1 again, and a3. So you'd say 6 minus, you'd get 2a1, and the 2a1, where is it? It's plus 6a3. This one is equal to 0, which is what you do. You get a relationship. Oh, you'll be just taking the constants. It shouldn't be hard, and then you equate to 0. Okay. Once you do that, you are going to have relationships for each. Then you are going to put in the original y, because you have told us what your y is going to be. It's going to be this. Then now you do Frobenius. That Frobenius one. Here it's about comparing. I think you've seen in a way. Frobenius will now be find the power c. Use the Frobenius method to find blah 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 the power series of this following thing. For Frobenius, we have this y, our y. Remember x0c plus 1. Okay, so for this one, I don't want you to use x1 and stuff. I want you to use powers, so it becomes x squared, x to the 3. So this is going to be Frobenius is x a0 a1 a2c plus 2a rc plus r. What we're going to do to Frobenius is, once we have our y, we'll get all those things that are inside him, inside his question, okay? To solve Frobenius, there is the second derivative, first derivative, and then there is you'd get all those things. So you can have him. Yeah, you can have this. What you do is you differentiate, you get all this, you put them in like that, you make it equal to 0. That is in Frobenius. Then what you're going to do is you're going to take, in that thing, you're going to take the thing with the lowest power. Thing with the lowest power in Frobenius, you make it equal to 0, you solve the equation, whatever you're going to get. Okay? Then once you have it like this for your Frobenius, now what you must then do is, you're going to take the lowest power, you make it equal to 0, to find what we call the initial equations, to find two values for c. Once you find them, this is how you'd be doing it. Now, once you have, yes, you should know, once you have these 3x, you multiply by the second derivative, you have dy dx, then you multiply minus on the y, because you know what y is from Frobenius. It doesn't change. Dy dx, then 3x multiplying that. Then we said you're going to pick the number with the lowest power, and you let it equal to 0, so you find the values for c. When you find the values for c, what are you going to do with them? What is the importance for you to find the values of c? You're going to take them back and start feeding them to find your solution. I'm seeing something which is a bit haphazard here, but I wanted to show how you're going to feed it back into the thing to find your solutions. When you find your two c's, you are going to feed it back into the solution to find each of the things, to find a1, to find a2, to find a3, to find whatever. And you'll be making each of these things. So when you put your c, it should make whatever you were having, if you're trying to resolve it, whatever, make it actually equal to 0, then you can find the other thing. Okay? This is bad. Anyway, I think people get. I don't know if a lot of people want it for BDS anyway. That is it.